Hello, in this lecture we will find the area of the green shape. In the drawing we have triangle ABC. We know that angle BAC equals to 60 degrees, and we also know that BF equals to CF. BF equals to CF, and FC or CF equals to DF equals to EF. So all the sides here, BF, DF, EF and CF are equal to each other, and we also know that the area of triangle BDF, this triangle, equals to 8 square units, and the area of triangle EFC equals to 15 square units. And we want to find out the area of the green shape, actually the area of the quadrilateral ADFEC. Okay, so first of all we will define angle ABC as B, and we will define angle ACB as C, and we have a rule number 1 that states that the sum of the angles in any triangle equals to 180 degrees. The sum of the angles in any triangle is equal to 180 degrees. Okay, the sum of the angles in any triangle is equal to 180 degrees. I will read rule number 1 again. Rule number 1 states that the sum of the angles in any triangle is equal to 180 degrees. So actually, especially in triangle ABC, the sum of the angles is equal to 180 degrees. That is to say 60 degrees plus angle B plus angle C equals to 180 degrees according to rule number 1. Okay, 60 degrees plus angle B plus angle C equals to 180 degrees. Here we will subtract 60 degrees from this equality. It will be equation number 1. Equation number 1, B plus C equals to 180 degrees. Okay, B plus C equals to 180 degrees. Then we have also rule number 2 that states that in front of equal angles in the triangle, there are in front of equal sides in the triangles, there are equal angles. In front of equal sides in the triangle, there are equal angles. I will read rule number 1 again. Rule number 2 again. Rule number 2 states that in front of equal sides in the triangle, there are equal angles. So actually, triangle BDF, this triangle has two sides that are equal to each other. Side BF equals to side DF, and in front of side DF we have angle beta. So in front of angle BF there must be the same angle. So angle BDF also must be equal to beta according to rule number 2, that in front of equal sides in the triangle there are equal angles. Those two angles are located in front of equal sides, therefore they also must be equal to each other. So if this angle is beta and the other angle must be equal to beta, angle BDF must be equal to beta. And the same thing is true in triangle EFC. We have side FC that equals to side FE. So in front of side FE we have angle C. So in front of side FC that equals to FE, there must be same angle according to rule number 2, that in front of equal sides in the triangle there are equal angles. In front of side FC that equals to FE, actually in front of side FE we have angle C. So in front of side FC that equals to FE we must have the same angle, that is to say it must be equal to C. Okay, so in the next step we will define angle DFB as P, and we will define angle EFC as Q, and again we will use rule number 1 that states that the sum of the angles in any triangle equals to 180 degrees. So the sum of the angles in triangle BDF equals to 180 degrees. That is to say angle B plus angle B, that is 2B plus angle P, must be equal to 180 degrees. Okay, that is according to rule number 1 that states that the sum of the angles in any triangle equals to 180 degrees. And here we will subtract from this equality 2B, and we will get that angle P equals to 180 degrees minus 2B. Okay, angle P equals to 180 degrees minus 2B. Then we will do the same thing in triangle FEC. In triangle FEC, the sum of the angles is equal to 180 degrees. That is to say C plus Q equals to 180 degrees, or 2C plus Q equals to 180 degrees. So here we will subtract 2C from this equality, and we will get that Q equals to 180 degrees minus 2C. Okay, so we got the values of P and Q. In the next step, we will add together P and Q in both sides of the equation. We will add P plus Q in both sides of the equations. So P plus Q, that will be equation number 2, equals to 180 degrees plus 180 degrees equals to 360 degrees minus 2B minus 2C. Okay, so P plus Q equals to 360 degrees. Here we will take a common factor of minus 2 from this expression, minus 2, and inside the brackets we have B plus C. B plus C. So in total we got question number 2 that states that P plus Q equals to 360 degrees minus 2 times B plus C. But from equation number 1 we know that B plus C equals to 180 degrees, so we can substitute B plus C by 120 degrees. Again, we have equation number 1 that states that B plus C equals to 120 degrees, so we can substitute P plus C from equation number 2 by 180 degrees. Okay, so we will do it now. So P plus Q will be equal to 360 degrees minus 2 times, we will substitute by B plus C by 180 degrees, or P plus Q equals to 360 degrees minus 2 times 180 degrees is 240 degrees. So we got that P plus Q equals to 360 degrees minus 240 degrees, that is actually 120 degrees. So equation number 2 states that P plus Q equals to 120 degrees, and we have already found out in equation number 1 that B plus C equals also to 120 degrees. Okay, you have equation number 1 that states that B plus C equals to 180 degrees, and we have equation number 2 that states that P plus Q equals to 120 degrees. Okay, in the next step we will find the size of angle DFE. Okay, according to the rule that the sum of the angles on a straight line equals to 180 degrees. Okay, we have actually rule number 2 that states that the sum of the angles actually it is rule number 3. Rule number 3 states that the sum of the angles on a straight line is equal to 180 degrees. So I will read rule number 3 again. Rule number 3 states that the sum of the angles on a straight line is equal to 180 degrees. So according to rule number 3, we know that BC is a straight line. So the sum of the angles on that straight line, and the straight line BC at point F, must be equal to 180 degrees. Actually, angle P plus angle DFE, this angle, plus angle Q must be equal to 180 degrees according to rule number 3. Again, angle P plus angle DFE plus angle Q must be equal to 180 degrees according to rule number 3. But we have already found out that P plus Q equals to 120 degrees according to rule number 2. So we can substitute P plus Q by 120 degrees. Okay, so angle DFE plus angle P plus Q is 120 degrees, must be equal to 180 degrees. So here we will subtract 180 degrees from this equality, and we will get that angle DFE equals to 180 degrees minus 120 degrees is 60 degrees. Okay, we found out that angle DFE, this angle, equals to 60 degrees. Okay. In the next step, we will connect together points D and E by a straight line. Actually, in triangle DFE, we have two sides that are equal to each other. DF equals to FE in triangle DFE. Therefore, according to rule number 2, the angles that are in front of equal sides are equal to each other. So those two angles are equal to each other. Let's define those two angles as y. So those angles are equal to each other. So if this angle is y, the other angle also must be equal to y. And again, according to rule number 1, the sum of the angles in the triangle, in any triangle, and especially in triangle DFE, must be equal to 180 degrees. So y plus y, that is 2y, plus 60 degrees must be equal to 180 degrees. Again, the sum of the angles in triangle DFE, the sum of the angles is equal to 180 degrees. Again, in triangle DFE, the sum of the angles equals to 180 degrees. That is to say, y plus 60 degrees equals to 180 degrees. Here we will subtract 60 degrees from this equality, and we will get that 2y equals to 180 degrees minus 60 degrees is 120 degrees. So here we will divide this equality by 2, and we will get that y equals to 60 degrees. Okay, y equals to 60 degrees. That is to say, this angle is a right angle, it equals to 60 degrees. This angle equals to 60 degrees. Here also y equals to 60 degrees. So this angle is also equals to 60 degrees. So actually, triangle DFE is an equilateral triangle. That is to say, all its sides are equal to each other. So side DE equals to side FE equals to side DF. So if we define side BF as x, then all the other sides will be also equal to x, because those two sides are equal to each other according to what is given us in the question. So here we have x, x, and x. Okay. So in the next step, we will focus on triangle ADE, and we will find out the size of those two angles, angle ADE and angle AED. Again, according to rule number 3, that states that the sum of the angles on a straight line is equal to 180 degrees. So actually, AB is a straight line. So if we focus on point D, according to rule number 3, the sum of the angles at point D on the straight line AB must be equal to 180 degrees. That is to say, angle B plus 60 degrees plus angle ADE must be equal to 180 degrees according to rule number 3. According to rule number 3, that states that the sum of the angles on a straight line is equal to 180 degrees. Okay, so here we will subtract 60 degrees and also B from this equality, and we'll get the value of angle ADE that we want to find out. The value of angle ADE equals to 180 degrees minus 60 degrees is 120 degrees minus B. Okay, angle ADE equals to 180 degrees minus B. What according to equation number 1, B plus C equals to 180 degrees. 120 degrees. According to equation number 1, B plus C equals to 180 degrees. So actually, if we subtract from equation number 1 C, if we subtract from equation number 1 B, we will get that C equals to 120 degrees minus C, minus B. We subtracted B. So C equals, according to equation number 1, C equals to 120 degrees minus B. So here we can write that angle ADE equals to 180 degrees and minus B, and 180 degrees minus B, according to equation number 1, equals to C. 180 degrees minus B equals to C, according to equation number 1. So we found out that angle ADE equals to C. Okay, so angle ADE equals to C. So we will repeat on the same process at point E. We know that AC is a straight line, so at point E, on the straight line AC, the sum of the angles are equal to 180 degrees. Therefore, angle C plus 60 degrees plus angle DEA must be equal to 180 degrees according to equation according to rule number 3, that states that the sum of the angles on a straight line is equal to 180 degrees. Okay, so here again we'll subtract 60 degrees and C from this equality, and we will get that angle DEA equals to 180 degrees minus 60 degrees is 120 degrees minus C. Angle DEA equals to 180 degrees minus C. Okay, again I will write it again here. We found out that angle DEA equals to 120 degrees minus C. Okay, angle DEA equals to 120 degrees minus C. Okay, but according to equation number 1, B plus C equals to 120 degrees. So if we subtract from equation number 1 C, we will get that B equals to 120 degrees minus C. Okay, B equals to 120 degrees minus C. So actually here we have 180 degrees, 20 degrees minus C. It equals to B according to equation number 1. So we can add here to this equality that 180 20 degrees minus C equals to B according to equation number 1. And actually, from this equality, we can derive that angle DEA equals to B. Okay, from this equality, we can derive that angle DEA equals to B. So, angle DEA equals to B. Okay? So, actually, as you can see from the drawing, triangle DEA has three angles, 60 degrees, B and C. And triangle ABC has exactly the same angles. Triangle ABC has angles of 60 degrees, B and C. Therefore, the two triangles will be similar to each other. Okay, so we'll focus on triangle ABC, the big triangle ABC, and the small triangle ADE, this triangle. Angle AED in the small triangle, this angle AED, equals to angle ABC in the big triangle ABC. And both those two angles are equal to B. Again, angle AED equals to angle ABC, and both those two angles are equal to B. Okay, both those two angles are equal to B. And also angle ADE in the small triangle, this angle ADE equals to angle ACB in the big triangle ABC. And both those two angles are equal to C. Both those two angles are equal to C. Okay? Again, angle ADE equals to, in the small triangle, equals to angle ACB in triangle ABC, and both those two angles are equal to C. And we have the third angle, angle A, that is a common angle. It belongs both to the small triangle ADE, and angle A belongs also to the big triangle ABC. So angle A equals to angle A. It is a common angle. Again, angle A equals to angle A. It is a common angle. It belongs to both triangles, the small triangle ADE, and the big triangle ABC. Actually, we proved that all the three angles in triangle ABC equals to all the three angles in triangle AED. Therefore, we actually proved that triangle ABC is similar to triangle AED. I will write it down. Triangle ABC is similar to triangle AED according to angle similarity rule. Okay, triangle ABC is similar to triangle AED according to angle similarity rule. When you prove that two triangles are equal to each other by all angles, then those two triangles are similar to each other according to angle similarity rule. Okay, so triangle ABC is similar to triangle AED. From this similarity, we can derive the following thing. Actually, we have a rule. I will call it rule number 4. Rule number 4 states that the ratio between the areas of similar triangles is equal to the square ratio of their corresponding sides. So I will read rule number 4 again. Rule number 4 states that the ratio between the areas of similar triangles is equal to the square ratio of their corresponding sides. Again, the ratio between the areas of similar triangles is equal to the square ratio of their corresponding sides. So actually we will implement rule number 4 in our two similar triangles. According to rule number 4, the ratio between the area of triangle ABC actually this is the sign of area. This means actually the area of triangle ABC. Okay, so the ratio between triangle ABC, the ratio between the area of triangle ABC to the area of triangle AED according to rule number 4 is equal to the square ratio between their corresponding sides. So what is the square ratio of their corresponding sides? It is actually BC square over DE square. Okay, again, according to rule number 4, the ratio between the areas of triangle ABC to triangle AED is equal to the square ratio of their corresponding sides. That is to say, it equals to BC square over DE square. Okay, but what is the value of BC? BC, according to the drawing, equals to x plus x. So BC equals to 2x. So BC square is 2x square. And what is the value of DE? DE equals to x according to our definition. So DE square equals to x square. Okay, so in total we got that BC square over DE square equals to 2x square over x square. 2x square equals to 4x square. 4x square over x square. X square over x square is 1. So we left only with 4. So the ratio between the area of triangle ABC to the area of triangle AED is equal to 4 according to rule number 4. Okay, here we can multiply this equality by the area of triangle AED, and we will get that the area of triangle ABC is equal to 4 times the area of triangle AED. Okay, so triangle ABC is 4 times bigger in its area from triangle AED. Triangle ABC is 4 times bigger than this triangle, triangle AED. Okay, and what is the size of the area of the shape, the quadrilateral DBEC, this quadrilateral? What is the area of this quadrilateral? Actually, the area of this quadrilateral DBEC equals to the area of triangle ABC minus the area of the small triangle, triangle AED. Okay, so we can write down that the area of triangle DBE, you can see it, it is very simple from the drawing itself. The area of the big triangle ABC minus the area of the small triangle AED equals to the area of the quadrilateral DBEC. Okay, so the area of quadrilateral DBEC is equal to the area of triangle ABC minus the area of the small triangle, triangle AED. Again, a simple equality that states that the area of quadrilateral DBEC equals to the area of triangle ABC minus the area of triangle AED. But we have already found out that the area of triangle ABC equals to 4 times the area of triangle AED. So we can substitute the area of triangle ABC by 4 times the area of triangle AED. So we will do it now, and we will get that the area of the quadrilateral DBEC equals to the area of triangle ABC, that is 4 times the area of triangle AED minus the area of triangle AED. So we have here 4 times the area of triangle AED minus 1 times the area of triangle AED. It equals to 3 times the area of triangle AED. So we actually found out that the area of the quadrilateral DBEC is equal to 3 times the area of triangle AED. Okay, and we also have already found out that the area of triangle ABC is 4 times the area of triangle AED. 4 times the area of triangle AED. Okay, so we have these two equalities. The area of triangle, the quadrilateral DBEC equals to 3 times the area of triangle AED, and the area of triangle ABC equals 4 times the area of triangle AED, the area of this triangle, small triangle AED. Okay, so in the next step, I will present you a formula for the area of any triangle. So if we have triangle ABC and we know that the size of side AB is A, the size of side AC is B, and the angle between AB and AC is theta, then the area of this triangle, triangle ABC, is equal to A times B times sine theta over 2. Okay, so that is the formula for the area of any triangle. The area of any triangle equals to the multiplication of the two sides by each other times sinus the angle between those two sides. Okay, A times B times sine theta over 2 is the area of this triangle, triangle ABC. So we'll use this formula in order to find out the areas of triangle EFC and triangle DFB. Actually, we know that the area of triangle DFB is 8 and the area of triangle EFC is 15, but we will use the formula to calculate the area that we have already know that the size of the area of this triangle is 15 square units and the size of the area of this triangle is 8 square units. So the area, first of all, the ratio between the areas of those two triangles is 15 over 8. 15 over 8. So the area of this triangle, triangle EFC, is equal to 15 square units, and according to the formula that I presented to you, the formula for the area of this triangle will be equal to x times sine q over 2. Okay, so the area of triangle EFC will be equal to x times x is x squared times sine q over 2. And likewise, the area of triangle DFC according to the formula that I presented to you for the area of the triangle will be equal to x times sine p over 2. Okay, so it is actually x squared times sine p over 2. Okay, so again we know that the area of triangle EFC equals to 15, and the formula for the area of this triangle is x squared times sine q over 2, and the area of triangle DBF that is equal to 8 is actually x squared times sine p over 2. So here 2 will be cancelled. Okay, so I write it down. So we got here that x squared times sine q over 2 equals to x squared times sine p, and 2 will be moved to the numerator, all equals to 15 over 8. So we got this equality. So here 2 over 2 is 1, 2 over 2 is cancelled, x squared over x squared is 1, so x squared is also cancelled. So in total what is left here after we cancelled x squared and 2, what is left is sine q over sine p equals to 15 over 8. Okay, so we got this equality, sine q over sine p equals to 15 over 8, but we have already found out in equation number 2 that q plus p equals to 180 degrees. According to equation number 2, q plus p equals to 120 degrees. That is equation number 2. So from equation number 2 we can subtract p, and we will get that q equals to 120 degrees minus p. Okay, q equals to 120 degrees minus p. So here we can substitute q in this equality by 120 degrees minus p, because q equals to 120 degrees minus p according to equation number 2. So we will do it now, and we will get that sine q is, according to equation number 2, is 120 degrees minus p over sine p equals to 15 over 8. Okay, So we got this equality that sine 120 degrees minus p equal over sine p equals to 15 over 8. So here we have trigonometric identity for the value of sine 120 degrees minus b. It is like sine a minus b. And actually sine a minus b equals to sine a cosine b minus sine b cosine a. Okay, so we have this trigonometric identity for sine a minus b. According to this trigonometric identity, sine a minus b equals to sine a cosine b minus sine b cosine a. So we will use this trigonometric identity in order to find the value of sine 120 degrees minus p. Okay, so sine 120 degrees minus p, according to this trigonometric identity, will be equal to sine 120 degrees times cosine p minus sine p times cosine 120 degrees. Okay, again, according the value of sine 180 degrees minus p according to this trigonometric identity equals to sine 20 degrees times cosine p minus sine p times cosine 120 degrees. Okay, so it is actually equal, sine 120 degrees is root 3 over 2 times cosine p minus sine p, and cosine 120 degrees is minus 1 over 2 . Okay, so that is the value of sine 120 degrees minus p according to this trigonometric identity. But we have our formula, so we will substitute from this equality, we will substitute sine 120 degrees minus p by what we found according to this trigonometric identity. So we will get that our equality is sine 120 degrees minus p is root 3 over 2 times cosine p over sine p here we have minus times minus is plus 1 over 2 times sine p over sine p. Sine p over sine p is 1, so sine p is cancelled. Can cancel sine p over sine p, and all equals to 15 over 8. 15 over 8. Okay. So we got this equality after we substituted sine 120 degrees by this expression that equals to sine 120 degrees minus p. So here we have cosine p over sine p is actually cotangent p. Okay, so we write down that root 3 over 2 and cosine p over sine p equals to cotangent p, and sine p over sine p is 1, so what is left here is only half equals to 15 over 8. So in total we found out that root 3 over 2 here cotangent p equals to 1 over tangent p. So we'll substitute cotangent p by 1 over tangent p, and we will subtract minus 1. We will subtract 1 over 2 from this equality, and we will get that here 1 half minus 1 over 2 minus 1 over 2 is 0, and in the other side of the equality we will have 15 over 8 minus 1 over 2 is 4 over 8. So in total we got this equality that root 3 over 2 times tangent p equals to 15 over 8 minus 4 over 8. 15 minus 4 is 11. So I write it down. So in total we got that root 3 over 2 times tangent p equals to 11 over 8. Okay, we got this equality that root 3 over 2 times tangent p equals to 11 over 8. So here we will multiply this equality by tangent p in order to get the value of tangent p. We will get that 11 over 8 times tangent p equals to root 3 over 2. Okay, so we got that 11 over 8 times tangent p equals to root 3 over 2. Here we will multiply this equality by 8 and then we will divide it by 11 in order to get the value of tangent p. Okay, so tangent p will be equal to root 3 times 8 over 2 times 11. Okay, here 8 over 2 is 4, so I write it down. We will get that tangent p equals to root 3 times 4 over 11. Okay, so we found out the value of tangent P. Tangent P equals to root 3 times 4 over 11. So actually tangent P, or tangents in general, is the relationship between the sides of a right triangle. So if we have a right triangle, if we have this right triangle with angle P, then tangent P is the ratio between the side that is in front of angle P over the side that is near angle P. So here we can write that the side that is in front of angle P is root 3 over 4, and the side that is near angle P is 11. So the hypotenuse will be equal to root 3 times 4 square plus 11 square. Okay, so actually sine P equals to root the side that is in front of angle P, that is root 3 times 4 over the hypotenuse, that is actually root 3 over 4 square plus 11 square. That is actually equals to 4 times root 3 over here root 3 times 4 square is actually 48, plus 11 square is 121, and 121 plus 48 is 169, and the root of 169 is 13. So we found out that sine P equals to 4 times root 3 over 13. Okay, sine P equals to 4 times root 3 over 13. Okay, and actually we know that the area of triangle DBF equals to x squared times sine P over 2. X squared times sine P over 2 is the area of triangle DBF, and we know that the area equals to 8 units. Okay, so that is the area of triangle DBF. Okay, this is the area of triangle DBF. Again, the area of triangle DBF equals to x squared times sine p over 2, and we know that it is equal to 8 square units. But we have already found out that sine x equals to sine p. Sine p equals to 4 times root 3 over 13. So we can substitute sine p in this equality by 4 times root 3 over 13, and we will get that x squared over 2 times 4 times root 3 over 13 equals to 8. So here 4 times 2 is 2. So in total we will get that x squared times 2 times root 3 over 13 equals to 8. Here we can divide this equality by 2, and we will get that root 3 times x squared over 13 equals to 4, because we divided this equality by 2. So here we will multiply this equality by 13, and then we will divide it by root 3, and we will get that x squared equals to 13 times 4 is 52, and 52 over root 3 is the value of x squared. So we found out that x squared equals to 52 over root 3. Okay, but what is the area of the equilateral triangle DEF? The area of the equilateral triangle DEF is equal to, according to our special formula, equals to x times sine 60. X times x is x squared, times sine 60 is root 3 over 2, all divided by 2. So it is actually all divided by 2, and we have already 2 in the denominator, so it is 2 times 2 is 4. So the area of triangle DEF equals to x squared times root 3 over 4. But we have already found out that x squared equals to 52 over root 3. So we can substitute x squared in this equality by 52 over root 3. So we will do it now, and we will get the area of the equilateral triangle DEF. So the area of the equilateral triangle DEF will be equal to x squared. X squared equals to 52 over root 3, and it is multiplied by root 3 over 4. So here we have root 3 over root 3 is 1, and 52 over 4 is 13. So we found out that the area of the equilateral triangle DEF equals to 13 square units. Again, the area of the equilateral triangle DEF equals to 13 square units. Okay, so we can write here that the area of this equilateral triangle DEF equals to 13 units. So actually now we can calculate the area of the quadrilateral DBEC. The area of the quadrilateral DBEC equals to the areas of three triangles that it consists. it consists triangle DBC that is area that its area is 8 units, 8 square units, and it consists the area. It consists the equilateral triangle DFE that we have already found out that the area of the equilateral triangle is 13 square units, and the equilateral DBEC also consists triangle that its area is 15 square units. So in total, the area of the equilateral DBEC, the area of the quadrilateral DBEC, the area of the quadrilateral DBEC equals to 8 plus 13, that is 21, plus 15 is 36. So we found out that the area of the quadrilateral DBEC equals to 36 square units. DBEC equals to the area of the quadrilateral DBEC equals to 36 square units. Okay, but we have already found out that the area of the quadrilateral DBEC equals 3 times the area of triangle AED. Okay, we have already found out that the area of the quadrilateral DBEC equals to 3 times the area of triangle AED. And we know that the area of the quadrilateral DBEC equals to 36. Okay, so we can divide this equality by 3, and we will get that the area of triangle AED equals to 36 over 3 is 12 square units. So we found out that the area of triangle AED equals to 12 units. The area of triangle AED equals to 12 units. So now we know that the area of the green shape equals to the area of triangle AED, that is 12, plus the area of the equilateral triangle DEC, that is 13. So the area of the green shape equals to 12 plus 13, that is 25 square units. Okay, so we can write down that the area of the green shape, we can also say that the area of the area of the shape ADEC the area of shape ADEF, the green shape, equals to 13 plus 12, that is 25. So the area of the green shape equals to 25 square units. Okay, so the area of quadrilateral ADEF, the green in the green color, equals to 25 square units. Okay, the area of the green shape equals to 25 square units. Okay, so now I will summarize the lecture. So we actually wanted to find out the area of the green shape. we know that in triangle ABC, angle BAC equals to 60 degrees, and also we know that BF equals to CF equals to DF equals to EF, and we also know that the area of triangle DBF equals to 8 square units, and the area of triangle EFC equals to 15 square units, and we want to find out the area of the green shape that consists of two triangles. So we have rule number 1 that says that the sum of the angles in any triangle is equal to 180 degrees, and especially the sum of the angles in triangle ABC equals to 180 degrees. Okay, the sum of the angles in any triangle is equal to 180 degrees according to rule number 1, and especially the sum of the angles in triangle ABC equals to 180 degrees. That is to say 60 degrees. We defined this angle ABC as B, and angle ACB as C. So 60 degrees plus angle B plus angle C equals to 180 degrees according to rule number 1. Here we subtracted 60 degrees from this equality, and we got that B plus C equals to 120 degrees. Then we have rule number 2 that states that in front of equal sides in the triangle there are equal angles. So actually in triangle DBF we have two equal sides, side DF equals to side BF, and we know that this angle is angle B, so angle FDB must also be equal to B because of rule number 2 that says that in front of equal sides there are equal angles. Those two angles are located in front of equal sides, therefore they are also equal to each other according to rule number 2. So if this angle is B, then this angle also must be equal to B. And we repeated on the same process in triangle FEC. In this triangle we have two sides that are equal to each other. Side EF equals to side FC, and according to rule number 2, in front of equal sides there are equal angles. So those two angles are equal to each other according to rule number 2, and we know that this angle is C, so this angle must be also equal to C according to rule number 2. Okay, and then we defined this angle as P, and we define this angle as Q, and then we operated rule number 1 again. We implemented rule number 1 again that states that the sum of the angles is equal to 180 degrees in any triangle. So we know that in triangle DBF the sum of the angles is equal to 180 degrees. So 2B plus B equals to 180 degrees in triangle DBP. So we can subtract 2B from this equality, and we got that angle P equals to 180 degrees minus 2B. And the same rule we have in triangle EFC. The sum of its angles is equal to 180 degrees, so C plus Q equals to 180 degrees. Okay, C plus Q is 2C plus Q equals to 180 degrees according to rule number 1. So here we subtracted 2C from this equality, and we got that the value of angle Q equals to 180 degrees minus 2C, while the value of angle P equals to 180 degrees minus 2B. Then we added together P and Q. We actually added together these two equalities. So in this side of the equation we have P plus Q, and in the other side of the equation we added those two equations together. 180 degrees plus 180 degrees is 360 degrees, and here we have minus 2B minus 2C. Then we actually got the common factor. We take out the common factor of 2 from this expression, and we got that P plus Q equals to 360 degrees minus 2 times B plus C. But we have already found out that B plus C equals to 120 degrees, so we can substitute B plus C in equation number 2 by 120 degrees. So we substituted B plus C by 120 degrees, and we found out that P plus Q actually equals to 120 degrees. So we actually have equation number 1 that states that B plus C equals to 120 degrees, and P plus Q also equals to 120 degrees according to equation number 2. Okay, and then we have rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. So we actually have we focused on the straight line AB. We know that the sum of the angles at any point of the straight line AB is equals to 180 degrees. So angle P plus angle Q plus angle ADE must be equal to 180 degrees. Okay. So actually before that we focused on the straight line BC. On the straight line BC, the sum of the angles are on the straight line equals to 180 degrees. So angle P plus angle Q plus angle DFE must be equal to 180 degrees according to rule number 3. So again, angle P plus angle Q plus this angle equals to 180 degrees. Again, angle P plus angle Q plus angle DFE must be equal to 180 degrees according to rule number 3. So here we know that P plus Q equals to 120 degrees. So we can substitute P plus Q by 120 degrees. We substituted P plus Q by 120 degrees. And then we subtracted from this equality 120 degrees, and we got the value of the size of angle DFE that is actually equals to 60 degrees. So the size of this angle is 60 degrees. Then we connected together points D and E by a straight line, and we know that EF equals to DF. Those two sides in triangle DFE are equal to each other. Therefore, those two angles are also must be equal to each other according to the rule that in front of equal sides in the triangle there are equal angles. So those two angles must be also equal to each other. So we defined one angle as y, so the other angle must be also equal to y because those two angles are equal to each other. And then we again implemented rule number 1 that says that the sum of the angles in triangle DEF equals to 180 degrees. So 60 degrees plus y must be equal to 120 degrees. Okay, 60 degrees plus y plus 60 degrees must be equal to 180 degrees. So 2y plus 60 degrees equals to 180 degrees. So here we subtracted 60 degrees from this equality and we got that 2y equals to 120 degrees. Here we divided this equality by 2 and we got the value of y equals to 60 degrees. Okay, so this angle is 60 degrees and this angle is also 60 degrees. So actually we have here an equilateral triangle. Triangle EFD is an equilateral triangle because all of its angles equals to 60 degrees. Therefore all its sides are equal also to each other, and if all the sides here are equal to x, and this side also will be equal to x. Okay, and then we found in triangle ADE we found the sizes of those two angles according to the rule that the sum of the angles on a straight line is equal to 180 degrees. Therefore angle B plus 60 degrees plus this angle must be equal to 180 degrees. Okay, so again, according to the rule that the sum of the angles on a straight line equals to 180 degrees, angle B plus 60 degrees plus angle ADE must be equal to 180 degrees. We subtracted 60 degrees from this equality and then we subtracted also B. We got that angle ADE equals to 180 degrees minus B. But we have equation number 1 that states that B plus C equals to 180 degrees. From equation number 1, we can subtract B and we will get that C equals to 120 degrees minus B. So here 180 degrees, 120 degrees minus B equals to C according to equation number 1. So from this equality we can derive that angle ADE equals to C. Angle ADE equals to C. Okay, and then we repeated on the same process in order to find out the size of this angle. We know that AC is a straight line, and again the sum of the angles on a straight line equals to 180 degrees. So C plus 60 degrees plus the size of this angle must be equal to 180 degrees. Again, C plus 60 degrees plus angle DEA, this angle must be equal to 180 degrees. So angle DEA must be equal to 120 degrees minus C. Okay, angle DEA must be equal to 120 degrees minus C. But we have equation number 1 that states that B plus C equals to 120 degrees. And if we subtract C from equation number 1, we will get this equation that B equals to 180 degrees minus C. So here we have 180 degrees minus C, and according to equation number 1, it equals to B. So we can write here that 180 degrees minus C equals to B according to equation number 1. So, and from this equality we can derive that angle DEA equals to B. Okay, angle DEA equals to B. And actually in triangle ADE we have 3 angles. One angle that is equals to 60 degrees, the other angle that is C, and the third angle that is B. Exactly like in triangle, the big triangle, triangle ABC, that is already angle of 60 degrees, angle B and angle C. So as you can see here that we have exactly the same angles on triangle ADE and on triangle ABC. So all the angles on the small triangle ADE are equal to all the angles on the big triangle, triangle ABC. Therefore, we can say that triangle ABC is similar to triangle AED according to angle similarity. Okay, so triangle AED is similar to triangle ABC. Okay, we have rule number 4 that states that the ratio between the areas of similar triangles is equal to the square ratio of their corresponding sides. So, according to rule number 4, the ratio between the area of triangle ABC to the area of triangle AED is equal to the square ratio of their corresponding sides. The square ratio of their corresponding sides is actually B square over DE square. Okay, so this equality is the implementation of rule number 4 in our 2 similar triangles. Okay, so BC equals to x plus x, that is 2x, and DE equals to x. So BC square is 2x square and DE square is x square. 2x square is 4x square and x square is x square. 4x square over x square is 4. So the ratio between the area of triangle ABC to the area of triangle AED is 4, or triangle ABC is 4 times bigger than triangle AED. That is one equality, and we also know that the area of quadrilateral DBEC will be equal to the area of triangle ABC minus the area of the small triangle ADE. Okay, again, the area of the quadrilateral DBED equals to the area of triangle ABC minus the area of the small triangle, triangle AED. But we have already found out that the area of triangle ABC is 4 times bigger than the area of triangle AED, so it is actually equals 4 times the area of the small triangle. So we substituted ABC by 4 times the area of the small triangle. So 4 times the area of the small triangle minus 1 times the area of the small triangle equals to 3 times the area of the small triangle. So the area of quadrilateral DBEC equals to 3 times the area of the small triangle, triangle AED, and the area of triangle ABC equals 4 times the area of triangle AED. Okay, then I presented to you a special formula for calculating the area of any triangle. In this triangle ABC, the area is A times B times sinus theta over 2. We can calculate the area of any triangle according to this formula, and we actually have here two triangles. We know that the area of triangle EFD equals to 15 units, and the area of triangle DBF equals to 8 units. So the area of the triangle EFB over the area of triangle DBF is 15 over 8. And what is the area of this triangle? It is actually x times sinus q over 2, according to the formula that I presented to you. Okay, the area of this triangle is x times sinus q over 2. X times sinus q over 2. And what is the area of this triangle? It is actually, again, it is x times sinus p over 2. X times sinus p over 2. Okay? So, here x square is 1 and 2 over 2 is 1, so x squared and 2 are cancelled, and what we left only with sinus q over sinus p equals to 15 over 8. We know that q plus p equals to 120 degrees. And if q plus p equals to 120 degrees, we can subtract from equation number 2 p, and we will get that q equals to 120 degrees minus p. So we can substitute q in this equality by 120 degrees minus p, because q equals to 120 degrees minus p. So we substituted q by 120 degrees minus p from on this equality, and we got this equality, the sine of 120 degrees minus p over sine p equals to 15 over 8. Okay, then I presented to you a trigonometric identity to calculate the value of sinus 120 degrees minus p. The trigonometric identity states that sinus A minus B equals to sine A times cosine B minus sine B times cosine A. We calculated the value of sine 120 degrees minus p according to this trigonometric identity, and we got this expression that equals to sine 120 degrees minus p, and then we actually substituted sine of 120 degrees minus p by this expression, and we got that tangent p equals to root 3 times 4 over 11, and when we have the value of tangent p, we also can calculate the value of sine p, because sine p equals to the size of the side that in front of angle p over the hypotenuse. And we know that the hypotenuse is the root of the sum of the squares. So sine p equals to 4 times root 3 over 13. Okay, we found out the value of sine p. And we have this triangle DBC, that we know that the area of triangle DBC equals to 8 square units. And what is the area of triangle ABC according to the special formula that I presented to you? It equals to x times x that is x squared times sine p over 2. Again, the area of triangle DBF, the small triangle, equals to x squared times sine p over 2 according to the formula that I presented to you. Okay? But we have already found out that sine p equals to 4 times root 3 over 13. So we can substitute sine p by 4 times root 3 over 13. We substituted sine p by this expression, and we found out that x squared equals to 52 over root 3. And what is the area of the equilateral triangle DFE? According to the special formula that I presented to you, it equals to x times sine 60 over 2. X times x is x squared, and sine 60 degrees is root 3 over 2. Root 3 over 2, and all divided by 2 is root 3 over 2 times 2. Root 3 over 2 times 2 is root 3 over 4. So the area of triangle DEF equals to x squared times root 3 over 4. And we have already found out that x squared equals to 52 over root 3. So we can substitute x squared in this equality by 52 over root 3. We substituted x squared by 52 over root 3, and we found out that the area of triangle DEF, the equilateral triangle, equals to 13 square units. The area of this equilateral triangle equals to 13 square units. Okay, but after we found the area of this equilateral triangle, we also know that the area of the quadrilateral DBEC equals to 8 plus 13 plus 15, because this quadrilateral contains exactly those three triangles, and the sum of the areas of those three triangles equals exactly to the area of the quadrilateral DBEC. Okay, so the area of triangle DBEC, the area of quadrilateral DBEC equals to 8 plus 13 plus 15, that is 36. The area of quadrilateral DBEC equals to 36 square units. But we have already found out that the area of quadrilateral DBEC equals to 3 times the area of triangle AED, 3 times of the area of this triangle. So in total, we know that the area of triangle DBEC, that equals to 36 square units, equals to 3 times the area of triangle AED. So here we have 36 equals to 3 times the area of triangle AED. We can divide this equality by 3. After we divided this equality by 3, we found out that the area of triangle AED equals to 12 square units. The area of this triangle AED equals to 12 square units. So the area of the green shape equals to 12 plus 13. The sum of the areas of those two triangles, that is 12 plus 13. 12 plus 13 is 25 units. So we found out that the area of quadrilateral ADEF, the green quadrilateral ADEF, equals to 25 square units. Okay? Thank you very much.